Let's just dive right in, shall we? Welcome to this explainer. Today we're doing something a bit different because we've brought in some really incredible graphics and animations to visualize something that is literally happening all around you, right at this very second. We're talking about that constant, invisible hum of digital activity. Whether you're streaming lossless audio, syncing your smartwatch, or sending a secure message, you're relying on a massive, completely unseen infrastructure. So we're going to break down the exact mechanics of our modern digital world, and we're animating the two absolute pillars of this entire system: data packets and frequencies.
It really all boils down to one deceptively simple question. How do we actually share things from far away? I mean, it's the fundamental puzzle that modern networks are solving every single millisecond of the day. Think about firing off a massive high-res photo to a friend halfway across the globe. How does it get there? It obviously doesn't physically travel, yet it perfectly replicates on their screen in literally the blink of an eye. That right there is the core challenge of telecommunication.
And you know, the word telecommunication itself actually gives the game away. It breaks down so elegantly into two ancient roots. You've got the Greek word tele, meaning far off, and the Latin word communicare, meaning to share. Put them together and it literally translates to sharing from far away. I just love that because it proves our goal as a species has always been simple human connection across these vast distances. Sure, our ancestors used smoke signals and messengers, but today, the how has evolved into something blistering fast and unbelievably precise. To really understand how we pull this off today, we've got to zoom way into the microscopic vehicles of our invisible highway. We've actually animated these to show you what's going on, because information isn't just sent as one big, clunky chunk. If you send a massive file over a network, it absolutely does not travel as one giant block. That would be completely inefficient, not to mention a total nightmare for errors. Instead, the network relies on these brilliant little micro vehicles called data packets. It's this highly structured split-second process. First, your file gets shattered into incredibly tiny parts. Next, those little parts just zip across the network, weaving through all sorts of crazy routes across the globe. And then finally, they're reassembled perfectly at the destination. So, the second you hit send, the network chops the data up, blasts it out into the world, and then seamlessly rebuilds it at the finish line so your friend sees the complete picture. No missing pixels, no glitches. Now, you might be wondering, why go through all that trouble? Well, breaking data down like this means significantly faster delivery and much higher reliability. Think about it. If one tiny packet drops, the network only has to resend that one tiny piece, not the entire gigabyte file. It's a total game changer for efficient communication over immense distances. Plus, every single packet acts like a microscopic envelope in the mail. It carries a highly specific sender and receiver address, perfectly labeled so absolutely nothing gets lost in transit. Okay, so if data packets are the vehicles carrying all our information, what exactly are the roads they're driving on? Whether it's a copper wire, fiber optics, or literally just thin air, these packets need some kind of medium to move through. And that brings us to the second half of our explainer, the invisible pathways that make all this wireless communication possible. The answer is frequency. In the telecommunications world, frequency simply refers to how often data signals are sent over a communication channel in a single second. You can basically visualize it as the literal pulse of our invisible highway. A faster pulse means way more information can get pushed through that invisible road in a much shorter amount of time, and different technologies deliberately use completely different frequency ranges to send their data. And honestly, this isn't just some dry concept for engineers. This dictates your entire daily life. Every single piece of wireless tech you touch absolutely relies on these specific frequency waves to function. We're talking about the Wi-Fi and Bluetooth connections right there in your home, the 4G and 5G networks powering the smartphone in your pocket, the radio and TV broadcasting you tune into, and even utility stuff like RFID systems for your smart cards, oh, and the microwave oven heating up your leftover dinner. Every single one relies on this fundamental pulse. To truly wrap our heads around this, we really need to understand the mind-boggling scale at which these frequencies are measured. We're measuring the invisible here, and because these waves move so unbelievably fast, the numbers get massive incredibly quickly. Let's pull up some graphics to really show the scale of this. Frequency is measured in hertz, which is just a fancy way of saying times per second. We start down at kilohertz, which is 1,000 times per second. Fast, right? But then we jump up a massive level to megahertz, which is 1,000,000 times per second. And then we climb all the way up to gigahertz. 1 billion. That's a 1 with 9 zeros. One single gigahertz represents a data signal wave oscillating 1 billion times in a single second.
It is almost impossible for the human brain to truly comprehend something vibrating or pulsing that fast, but it's exactly what makes modern, high-speed telecommunications possible. I mean, without that blistering speed, our tiny data packets would basically be stuck in perpetual rush-hour traffic.
So, how do all these abstract numbers and massive scales actually map out onto the devices sitting right there in your living room? Let's take a look at the real-world spectrum to see how this incredible speed enables the stuff we use every single day to share information from far away.
The contrast here is actually super cool. Take AM radio broadcasting, for instance. Operating down in the lower kilohertz ranges, these longer waves are fantastic for bouncing off the atmosphere and traveling crazy long distances at night. Now compare that to your 5G cellular networks, which use very high frequencies, specifically millimeter waves operating between 24 and 100 gigahertz. They are custom-built to carry massive amounts of data at lightning speed, but only over very short distances. So lower frequencies go far, but carry less data, while higher frequencies pack a massive punch over a much shorter sprint.
Check this out, because this is where it gets kind of wild. Notice how your Wi-Fi network, which uses 2.4 to 2.5 gigahertz to give you wireless internet at home, operates on an incredibly similar frequency range to your microwave oven. No joke, the invisible waves agitating water molecules to warm up your leftover pizza and the ones streaming this explainer to your screen right now are literally sharing the exact same neighborhood on the frequency highway. Meanwhile, beaming your favorite music on FM radio operates way lower, down at 88 to 108 megahertz.
And right alongside them, Bluetooth is crowding into that same 2.4 to 2.5 gigahertz range to perfectly sync up your wireless earbuds. Drop down a bit, and you've got RFID operating between 860 and 960 megahertz, triggering inventory tracking and letting you tap your smart cards. And then, of course, we have traditional television broadcasting using UHF signals between 470 and 890 megahertz to beam digital TV straight to your living room. It is a highly organized, heavily regulated spectrum that ensures all these different invisible vehicles don't just crash into one another.
So, as we wrap up this explainer, I really want to leave you with a final kind of mind-bending thought. How many invisible data packets and frequencies are passing right through you at this exact moment? Seriously, look around your room right now. Between the Wi-Fi bouncing off the walls, the Bluetooth talking to your smartwatch, the ultra-fast 5G cellular networks outside, and radio stations miles and miles away, you are sitting smack in the middle of a bustling, invisible highway of communication. Billions of tiny data packets riding on waves oscillating millions or billions of times a second, constantly working to achieve that ancient goal, sharing the world from far away. It is an absolute marvel of technology. Thanks so much for exploring this with me, and definitely keep questioning the invisible world around you.